My name is Pablo Garcia. I go by Poly, Poly Garcia. I'm gonna do this tutorial called Django Bootstrapping done right. It's actually about, a tutorial about setting up a Django development environment and playing around with different tools that we've been using at Vartis. So at Vartis, we started working with Django back in 2009. And we've gone through different repetitions of how to do things, okay? How do we run tests? So how do we deploy an environment to an application to an environment? How do we make sure that all the developers are running the same checks on their local environments, and so on. So this is not a recommendation on how to do things for production environments. It's just like, think about it as a playground to grab a Django application and configure different things that may not be on the Django tutorial or the standard Django tutorial. And I will guide you through setting up these tools or these external applications. This is a hands-on tutorial. Okay, so when I give this tutorial on site, I try to follow up with people doing this. I really encourage you to do this on your side. I mean, if you, I will let you during the talk. I will give you some minutes to follow up with this README file, which has all the instructions. And we will cover different things, such as setting a development environment with Docker, installing Python 3, and see how to install Python and make sure that you are using the correct and the isolated Python environment, dependency management, and we will review the project structure and how to configure your application and other things. So during the tutorial, I will be covering these items on the README file, and I will give you some time to do it on your own. Okay, so try to do the exercises, and there are some exercises also. There are some instructions and also some exercises. Try to do both on your end. If you get stuck or if you have any problems, just raise your hand. Calvin will be monitoring the comments on the streaming platform, and also on Zoom. So reach out. I mean, don't be shy. Interrupt me if you want me to clarify something, and try to follow up. And because I would like you to all of you to be able to set this project up. Okay, so let's get started. Okay, so in order to set this up, first, there are some dependencies that we're going to use. One is Docker. Okay, I mean, I have Docker installed on my environment right now. You can verify if you have Docker or not by issuing Docker -v. So you can see that you have, for instance, I have Docker version 1903. If you install Docker right now, it may take some minutes. So try to shoot now because we're going to try to use Docker to try some things. And we will also use Docker Compose. If you use Docker Desktop on Mac, Docker Compose comes bundled on it. If you use Windows or Linux, you will need to install it separately. Docker Compose is a script that helps you manage multiple Docker containers at once. We will see that later. I'm going to try to explain what a Docker image and what a Docker container is later. But with Compose, you can manage multiple instances of running Docker images at the same time. Okay, we will be using that too. Okay, so I will verify that I have Docker Compose installed by issuing a -v also, so I can see that I have this version of Docker Compose running. Okay, so again, please try to install Docker and Docker Compose because we will be using it during the tutorial session. Okay, Python 3. As you all know, Python 3 is the current, well, it's the recommended version of Python. Python 2 has reached its end of life on January the 1st this year. Your systems may have Python 2 installed by default. I mean, if I issue a Python maintenance version, I have a 2.7 on my Mac. Okay, so make sure that you're using Python 3. Okay, on this tutorial and on any Python project that you start from scratch. Sometimes at Vartis, I have to work on older applications. Some of them may be still using Python 2. It's very frustrating, and we usually try to encourage our customers to migrate to Python 3, their applications. So there's one thing that I want to discuss here, and it's that you need to be aware of the Python version that you're using when you are working on a Python project. Okay, it's very important, and there are some tools that let you manage the Python version that you are using. Okay, so for instance, I use Pyenv for this. Okay, Pyenv lets you manage Python version that you use on your system. Okay, and lets you change the Python interpreter that you use on your project. Okay, so you can very easily using Pyenv, you can say, okay, I want to use locally on this directory, I want to use 3.6.10. Okay, so now if I issue Python maintenance version, okay, now I have Python 3.6. Or I can say again, okay, I want to use Python the system, Python system, Python total. I don't know, 2.7.6, for instance. I'm sorry, Pyenv local system, and I get back to use the system Python version. Okay, so I am going to use this to set up the Python version of the Python interpreter I'm going to use. I just want to do this small introduction so that you know that when you are working on a project that requires a specific Python version, you can install it with Pyenv very easily. Okay, but we're not covering installing Pyenv right now. Okay, so another thing that we are going to use is Node.js. Okay, we're going to use Node.js during the build process of the development environment. There are some checks that we do with Node, such as code duplication on the local development environment. we encourage developers to run the build process that is run on the CI environment, so that they can detect any errors that or non-conformances, non-conformance issues on their development environment, instead of doing that on the integration environment. So one of the things that this boilerplate Django project does is to detect for code duplications in your project, and if this plugin detects more than 5 or 6 lines of duplicated code, the build will fail, and you will be prompted to try to find a different solution for the code that you are duplicating. And then we are going to use a Python IDE or a text editor. You can use PyCharm. It's I think that is the best Python development environment. You can use Visual Studio Code, Sublime, or Atom. I will personally use Visual Studio Code for this tutorial. I use it every day because I find it faster than using PyCharm to analyze code or do some small changes. But you can use whatever you choose to use. Okay, so let's start by getting the code of this project. So the URL of this project is bitbucket.org. I'm gonna increase the font size. It's on Bitbucket at the Advances account, and the project is called Django Bootstrap. I'm going to post this on Slack on the track 1 channel, so you can use the URL. I should have done this earlier. Okay, here it is. I posted on Slack. So there are different ways in which you can get the code of this project. I mean, you can fork the repository. Okay, and you do that by clicking on this plus sign on Bitbucket and using the fork this repository option. Okay, by doing this, you will be prompted to select a project. I have a Python Web Conference 2020 project already created. And you can change the name if you want. I'm going to fork it with the same name. And what this does, I mean, I'm not sure if you are familiarized with forking repositories, but this will make a copy of the project, which is independent of the root repository, but it keeps a relationship on it, okay, as a fork of the project, okay, and then you can submit if you want merge requests on the original project, okay. So right now I'm on my own fork of the repo, okay. If you don't want to fork the repository, you can also grab the code by cloning the repo. You can clone the repository, okay, and then renaming the origin, okay, the remote to something else, adding a new remote named origin to your Git repository, and then pushing all pushing all the commits to or the master branch to your own Git repository. I mean, it's up to you. There's one thing that when you do a fork, Bitbucket that does not allow it, that is to detach this fork relationship. Okay, so there's an issue on Bitbucket Jira that people is suggesting that you should be allowed to detach the fork from the upstream repository. I mean, if you can, please upvote this feature because it's useful. So you can like have your individual fork of the repo without the link to the original one. Okay, so back to the to my copy of this repository. Okay, so I'm gonna get the code now that I cloned this repository, and now that I forked this repository, I'm gonna clone it. Okay, I'm gonna copy this and paste it over here. Go ahead and grab your own copy of the project if you want. Now I have my Django Bootstrap folder here, okay, and I have all the code right away. So I'm going to open Visual Studio Code. I'm going to open this directory on Visual Studio Code. Okay, so I can now follow on the editor. Okay. Okay, so let's go back to the README file. Okay. Okay. Nice. Okay, so let's continue here. Okay, I'm gonna increase the font size so you can read with me. So where we are setting up our development environment. Okay, so you grab the code. I don't know if you have any questions regarding setting up this. I can continue if not. Okay, so now let's talk about the dependency management on your Python project. So if you work with software development projects, any technologies, you will know that keeping your development environment. I mean, if you worked on software development on a team, okay, on team environments, you will find that having your development dependencies, your project dependencies updated and up to date with the other members of your team, it's a problem, okay, that on the Python world, it is usually solved with pip. Okay, pip is a package manager that lets you install packages, and it also lets you generate requirements file that you can where you can put all your dependencies. Okay, and then if you use pip to install these requirements files, you will get all your dependencies in your development environment. The problem one of the problems with pip is that it doesn't discriminate the transitive dependencies from your direct dependencies. Okay, so if I say my project depends on Django, okay, I can put that on my requirements file. But that, of course, will, if I install Django, I mean, I will get a lot of other dependencies installed on top of it on my local environment. And then if I do a pip freeze, I will get a list of all these dependencies, and I cannot know whether which of those are my project's dependencies or are indirect dependencies. So Pipenv solved that by using a pip file, pipfile.log, a log file, which defines which are the direct dependencies and which are the transitive dependencies. I mean, it keeps tracks of the direct dependencies or the transitive ones. Okay. And another nice thing about Pipenv is that it also solves the dependency management, the virtual environments. Okay, so when you work with several Python projects, maybe at the same time. You want to be able to switch to quickly switch between different environments, and you don't want the dependencies of one Python project to mess up with the dependencies of other projects. To do that, we have a tool called virtualenv, okay, that lets you create a clean new environment and then install your dependencies there. Pipenv uses internally virtualenv to create virtual environments, but also manages the dependencies. So you would want, I mean, you have one tool that lets you do both things. There has been some criticism on Pipenv. One of the main issues of Pipenv is that it's quite slow, okay? When you are installing a new dependency, it takes a lot of time to calculate the transitive dependencies, the exact versions that you want to install, and puts everything on the log file. I mean, I leave this up to you. I mean, if you want, you can use Pipenv, or if you want, you can use Pip with your requirements file, or you can use Poetry, which is something that has been getting traction, a lot of traction lately. Pipenv was during 2009 pretty much dead in terms of development, but since March this year, I think it has got back to I mean, it's got back to have a good development pulse. Actually, there was a release done in early June, and I am using that version. Okay, so let's now set up my dependencies. Okay. Okay, I'm going to first of all, I'm going to set my local Python interpreter. Okay, with Pyenv. I want to use 374. Okay, so I have now Python 374, and then I'm going to I'm going to install, okay, Pipenv, okay, which I already have, but I encourage you to do this so that you can install Pipenv in your environment. Okay, make sure that you have Pipenv. Pipenv has other nice tools, such as this graph that lets you understand your dependencies. I'm going to run this in a few seconds. It has a shell command that lets you enable the virtual environment. So on my Pipenv file, on my pip file, I have said that the Python version required for this project is 3.6. Okay, because I wanted you to see that the difference between me working on with my local Python environment, or I get into the shell. Okay, what this is doing on background is creating the virtual environment. Okay, if I go into my shell, my Pipenv shell, I have Python 3.6. Okay, so if you have to work on a Python project with a specific Python version, you can use this tool. It comes really handy. Okay, so I'm out of my shell, and let's see the different things you can do with Pipenv. I'm going to follow the README directly on the browser because I keep getting lost on code. Okay, so let's create then a Pipenv with a with a specific version. Okay, so if I can tell Pipenv to create a Python 3 environment. Okay, 3.6 in this case. Pipenv. Okay, 3.6. I'm sorry, it's not version, it's a Python. It's Python. Okay, just create a Python with 3.6. Okay, you can again, you can shell into it. Okay, you can do your work. Then you can deactivate. I mean, if you see this at the left of your shell indicator, you will see that you have your environment enabled. Okay, and then if you exit, you disable it. You don't have any more this indicator on the left. You can also remove very easily your environment. Okay, if you want to start over from scratch, you can do it very easily. So now let's start let's create again the env, but let's tell Pipenv to install the dependencies. Okay. So let's take a look first at the dependencies that I have. So I'm having the base packages. I'm having Django 3.0, and I leave the patch version free. I have also Raven, which I use to use Sentry for error reporting. We have used this django-environ application to configure, to read the settings of the Django application. We're going to use Unicorn to run the application. We also use this Django extension project for some utilities, and the database engine that we're going to use is Postgres, and this is the driver. And White Nose is an application that lets you set up so to serve the static and media files from a heroic format, which we are going to set up during this tutorial. And then you have dev packages, which are packages that are only for development purposes. Okay, this is another nice thing also, and I think about Pipenv, in contrast to using pip alone. It lets you separate the packages that your application needs to run from the ones that you need in your local development environment. Okay, so we're using Pylint, Python Django, Faker to generate test data, Flick 8 for different checks, and PyTest to run the test. Okay. So let's install these dependencies. I'm going to use Python 3.6. Okay, so this generates a new virtual environment again, and now install my dependencies from the pip file log. Okay, this is important. So if you see here on the pip file, I'm saying that I want Django 3.0 star. Okay, but on my pip file log, I have a specific Django version. I am using 3.07. So if you set up this environment from scratch, you will install Pipenv will install the dependencies that are defined here on the log file. That way, we make sure that you and I are using the same dependencies. So it's if you have worked with Python for some time, you may have encountered the problem of helping someone else set up a development environment for a project you are working on, and that the dependencies they get installed on their environment are different from the ones that you have. This be because if you have on your requirements file used by pip a dependency expressed like this with a star, when you install this dependency, maybe Django 307 was the latest version, and maybe when you help a colleague in a few months, we will have Django 308 as the latest, and he will get Django 308. And that also happens with the transitive dependencies. Suppose that Django 307 depends on a library that has a star dependency definition. Maybe you will get that dependency installed for a specific version, and then when you recreate your environment, you will get a different version. So the log file makes sure that everyone on the team, and not only the team, but also on the CI environments and on the production or testing or QA environments, are using the same specific version that you want to use. Okay, so we have our environment here. Okay, so let's activate it. Pypenv shell. Okay. So now I can do a Python. I can just run Python. Okay, and let's see what version of Django I'm using. Django has a get version function. The top level module has a get version function that lets you see the Django version you're using. Okay, so basically it says that we're using Django 307. Okay, so I would like you to set your environment up. So I will give you a couple of minutes, like 3 minutes to complete this task, okay, and play around with the Pypenv installation. I don't know if you have any questions. If there are any questions out there for me, I will be happily answering them.
Yeah, don't be shy about asking questions. We've got Polly all to ourselves to make sure we're doing it right. Actually, I want to make a comment. We had been using Pypenv for a while, and then when it kind of went unmaintained for a little bit. They just had a release, so I recognize that. And we started using pip tools and pip tools compile to basically maintain like a bare minimum requirements than the pin requirements with hashes.
Okay.
It's definitely more work than Pypenv, but I was worried about Pypenv's project's health, but now it seems to be back on track.
Yeah, it seems to be back on track. I was really happy when I was reviewing the tutorial, revisiting the tutorial that Pypenv was back. Seems to be back on track. There was a release back in March with a ton of bugs fixed. There are a lot of issues still outstanding, but I think that the team is working on them. So I am happy to see the tool back on track.
I'll keep my fingers. Okay, so we switch back.
Yeah. And the other one to check is poetry also. I just played around with it. I didn't use it I didn't use it on any production project, but I would like to check it out.
So poetry has pyproject.yaml file, right?
Yeah.
Yeah, I'm interested in that.
Yeah. Okay, so if there are no questions or nobody needs help, I'm gonna keep up. Okay, so let's see the project structure. Okay, so this template has a project structure for Django applications. I mean, this is not something that we recommend as the truth, okay, on how to set up your Django projects. So we like to put all the configuration in a conf directory, okay, and have a settings file, and we have split the settings. This is pretty standard recommendations. You will, if you read PyDennis 2 scoops from Django book, you will see this right away. We have a base settings file, okay, and we read all the environments variables. We don't hard code any. Well, here we have one, but it's all written. But we try not to hard code any setting here. Okay. We try to use as much as we can environment variables to set up the different settings of the file. Okay, and the ones that have values, these are then overridden on the different specific settings file. Okay, the base is just a boilerplate for the other settings files. So the way this is structured is that there's a .env file in your settings directory. Okay, we have a sample here that you have to copy on your environment, and here you should be putting all your settings. Okay, and then the actual settings file will take those values from your .env and will configure your application. Okay, we are using django-environ for this. Okay, which is a Django application that lets you set up easily read this M file and set up, for instance, your database settings with just one variable, such as this one. Okay. So then we have the orals and the WSG py file. I'm gonna skip the project, the folder. And we have a scripts directory where we have some hooks, some Git hooks that we will cover later. Okay. For instance, on pre-push, we check that there are no local changes, and we run Flicate, Pylint, PyTest, ESLint, and the copy-paste detector. Each of these have configuration files that you can tamper with. We offer, I mean, some specific configuration. You can disable some rules. Okay, on Pylint, for instance, here. For Flicate, we also have some basic configuration, okay, that you can also tamper with or you can play with, and also with PyTest, okay. Then we have the Bitbucket pipelines file. We will see this later. The Docker Compose and the Docker file. More on this later also. And well, the package JSON that installs where we have the JS copy-paste detector installed. Okay, and also the proc file for Heroku. Okay, so now on this on the project directory, okay, you can name this after your project. I mean, this is just a template project. We have separated this onto apps and libs. Okay. On apps, we have just a common app with its own migrations, with its static resources, its templates, and its tests, okay? And with its URLs and the views, okay? And on the libraries, we usually put here code that is related to the different tabs that we manage. that we create during the development of a project, but not necessarily our Django related stuff. Okay, and the good thing about having this, I mean, on these sleeves we have like pure Python modules that we can then test easily. So we would set up tests for the Django apps, and also for anything that we have on the libs directory. So this is just a basic Django structure. I mean, you can follow this or this. I mean, this is not a recommendation again for a production environment. I mean, the aim of this tutorial is just that you play around with different tools that we are going to use, and not a recommendation of a production environment. To dig more on different recommended production environments for Django. Tomorrow there's a talk on Cutter, which is a tool to set up Django environments by following industry standard templates. Okay, so as I said, we have our base production, and we have our local example.py. Okay, we're going to use the example files to set up our local environment. Okay, so I'm going to copy the settings local example and create a new file called local.py. Okay, that is going to be my settings module. And I'm going to copy also the .env file, the sample.env file, and to my .env. So by doing this, I am providing my local development environment, whether I run it directly from like doing Django run server, or if I do it from Docker. I am providing my development, my environment variables and my settings. Okay, a small intro to Docker. Okay, so Docker is a tool to distribute software. Okay, like packaged software, and the way the way developers distribute software using Docker is by distributing images. Okay, the images are configurations of applications and procedures. Okay, they are run and are bundled and compiled on an image, and then you can take that image and you can run it. Okay, so when you run an image, you say that you have a container. Okay, a container is a running instance of the Docker image. Okay, so for instance, if you want to use PostgreSQL, PostgreSQL database on your project, I mean, instead of installing PostgreSQL on your computer, you can grab a Docker image of PostgreSQL, any version you want, and run it as a container. Okay. Suppose that you're working on different projects and you have different versions of PostgreSQL for them. You may want, you can use Docker to have multiple versions of PostgreSQL running, not at the same time, because Docker takes ports of your computer, but you can use it to when you switch from a project to another one, you can start your services and use different versions of your dependencies. Okay, so for instance, I'm going to run a container here that has Python installed on it. Okay. Okay, so by issuing the docker run command, okay, you will see, I mean, if you do this on your own, you will see a lot of output here of Docker downloading this specific Python image the 366 version. Okay. I didn't want to do this live because I mean it's going to take some time to download the images. But by doing this, I'm running a Python 366 environment. Okay. So on this shell, I am running code. I'm running commands inside the container. Okay. So if you want to get out of the container, you can just type exit and you get out of the container. The container will remain there. You can then delete it. I mean, this is the ID of the container. You can do a Docker and delete the container by just doing this. And when you run a container, there are different settings that you can set it on it. I mean, you can, for instance, start a container and tell the Docker engine that you want a specific directory on the system to be mounted on the container, and that you want everything that happens on a specific directory to be permanent and to be stored. Or else, I mean, if you restore the container, you will lose everything you do inside it. Or you can set environment variables to initialize it. We'll see this later. Or you can, for instance, also map ports. Okay, you can say, okay, I'm going to run this application, for instance, a database engine such as MySQL. Okay, and I want to map the 3306 port in my computer to the 3306 port of the container, which is the default MySQL port. Okay, so if I run this, this setting here and this one are environments that the way the MySQL image was created lets you suggest a root password and a database, a default database. Okay, so there are some images, or then when you run them, you are required to pass some environment variables to initialize the container. Okay, so I have now my MySQL database running. Okay, I'm gonna open a new terminal and connect to it. Okay, so I can do a MySQL. It's running on my localhost on port 3306, and I want to connect as the root user with the password. Okay, and the password is this one. So I'm in here now. So I can, I don't know, show databases. I mean, I have a DB database, which is the database that was initialized by issuing this environment variable. So if I use DB, and I can show tables. There is, of course, no tables because the database was initialized empty. Okay. So by this way, you can easily create a running instance of a MySQL server or any other software that you need. Okay, so what happened here? I tried to cancel to close this MySQL this container, and it is not allowing me to do it from here. So you can do it by using Docker commands. Okay, so if you issue a Docker PS, PS lets you see all the running containers that you have. Okay, every container has an ID. Okay, and it's using the MySQL default image. It tells you when it was created and the status. It's been running for 2 minutes. You can also see the ports that are bound and a name. Okay, Docker, if you don't specify a name, the Docker engine generates a name for your container. So I can tell the Docker engine to stop my container. And now if I go back to here, the Docker container has stopped. Okay. Okay, and you can also, you can also do the same. Okay, I don't know what happened with my terminal. Okay, well, it's a bit messed up. Well, but you can also do this docker run -d. Okay, this starts the container in daemon mode. Okay, and it will not. I thought something wrong happened with my terminal. Let's start a new one. The docker run -d. The -d flag runs the container on daemon mode, so your terminal will not get it will not get attached to your terminal. Okay. Now we can do a docker ps and see that it has a new name. Okay. And that it's been running for 5 seconds. Okay. You can then do a docker logs. This is the logs of your container, okay? And you can also stop it, okay? Okay, all right. Now, Docker Compose. As I said, before getting on to Docker Compose, I don't know if you have there are any questions about Docker, this very brief introduction to Docker. If not, I'll follow up with Docker Compose. Okay. So with Docker Compose, you can manage several containers at the same time. Okay. So suppose that your application depends on PostgreSQL and you have a Redis in memory key value store to, I don't know, that you use for a cache or something else. You can define those dependencies in your Docker Compose file. Okay. So we have a Docker Compose on this solution, which is here. Okay. And what this is doing is it is defining. This is a template. Okay, for the Docker Compose that define different settings for a Django app. Okay, but the important thing here is the services area. Here you define the services your application will be using. Okay, this Django service is the actual Django application that you are running or you are developing with. Okay, we use this to run development environments using Docker. If you want, you can start your Docker container with the Django app, and you can write code for your application, and the Docker environment, the Docker container will reload when you change code. And here we have a Postgres database, okay? And we set some development settings here, okay? These are just, this Docker file is just meant for development, okay? This is very important for you to understand. So here we initialize the image and the Docker engine when starting the Postgres container. We set, okay, a Postgres user called development, and the Postgres password called also the password of the user to development, and we create a database called development_database. Okay, that's why these settings and the port also should be used here. Okay, because when this container runs, it will communicate with the other container. Okay, we'll use the database defined in the other container. And the way the two containers communicate is by using the name of the service. Okay, on the Django container, on the network where this on the Docker network where these containers will run, the DB network name will be resolved to this running container. Okay. And then one more thing I wanted to add. So the Django app, I said that is this development environment. Okay. So how do we tell the Docker configuration, okay, or the Docker runtime environment or Docker image that we want to use, okay? So we do it by using this context and a dot, okay? So what this does is it looks for the Docker file, which is here. And here we're using Python 3.6 for this application. This is Docker file for the Django, for the development Django application, okay? We set some settings, some environment variables. Again, this is just for development purposes. Then when this image is built, it runs this command to install some dependencies. Here, for instance, we install Pipenv. It should be around here. Here it is. It installs Pipenv with pip, okay? And then copies the pip file from this directory on the log file, and install the dependencies. By doing this, whenever you you change the pip file, the pip file log, you need to rebuild this image, okay? And then it copies the project files, opens port 8000, and runs Python manage run server, okay? And you can access the application on port 8000. Okay, so let's see this in action. So as I said, there are different commands you can use from Docker Compose. Okay, let's try them. The PS also, as with Docker, lets you see which services defined in the Docker Compose files are running. We don't have anything running so far. So let's build the images that we need to run this application. Okay, by doing a Docker Compose build, it will build. So what this is doing is it is detecting that on the Docker Compose file we have a service that needs to be built. Okay, and what this is doing is building the Docker file. Okay, so here you see that all these commands here are being run when this is when the project is being built. Okay, when the container is when the image is being built. So again, if I do a PS, we have nothing running. Okay, so let's start our services. Okay, so I can issue a Docker Compose up, and this will start the services. The way Docker Compose start the services is it looks at dependencies, so which services are dependent between them. So here, on our Docker Compose file, we have a depends on directive that says that the Django app depends on DB. That is why the DB container is started first, okay, and then the Django container gets run. But this again grabs my terminal. I can open a new terminal and do a Docker Compose PS and see what is going on. And I see that these services are running. But also you can use the -d flag here, okay, Docker compose -d to, I'm sorry, up -d to start your services and recover your terminal, okay. I'm gonna close this one. Okay, so we have our terminal back, but what is going on? So we have these two containers running. The DB container is mapping the host, which is my computer, 5432 port to the container 5432 port. And the Django container is mapping the 8000 port. So I should be able to run, to browse to this application and see that we have something, okay? We have just view that returns this template with a link to the app. If I click here, this fails because we have not run the migrations yet, okay? So let's see how we can run commands inside our containers. Okay, so there are other commands that I'm gonna go over them later, but we have this exec command, okay? So I can, for instance, do a Docker compose exec, okay, and I tell that I want to run on the Django container a bash session, okay. Okay, there's no bash here. I can run a Python interpreter, okay. And I can do also, I don't know, I can run the Python manage py script, okay. Well, this is okay, yeah, the Pipenv here. As we are using Pipenv, we need to run Python with Pipenv, okay. What we're doing here is we're running on the Django container, Pipenv run, okay, to activate the virtual environment, and then run the manage command, okay. Okay, so now we're running the correct command. And of course, I need to run my migrations. Okay, so I can execute the migrate command, and this will run inside the Django container, the migrations, and affect the database. This will impact on the database directly. Okay, so now if I reload this, I will not get the error again. Okay. Of course, there are other commands such as stop. Okay, I can stop my my containers, or even I can do a down. The down command deletes the containers and the network, and you will lose, basically you lose your data. So now the application is not anymore running here. Okay, so there's an exercise that I would like you to do to start dealing with Docker and Docker Compose, and with the exec or run. So I would like you to do this exercise. I mean, take like 5 minutes to do it, and ask me if you have any questions. Please open up your microphones and do me any questions that you may have. I would like you to be able to run these commands against your containers. Okay. So go ahead and and start with compose up using the -d if you want flag your containers, and then you may want to, I don't know, open a shell. And of course, if you have any other question related to something else, feel free to do them. I will be happy to answer them. Okay, so if there are no questions, I can keep going. Okay, so let's start over and recreate our containers. Docker compose up. Okay, no, sorry, I had used the -d flag. Okay, so before doing that, so there's one thing that also comes handy. So if you don't want to run your development environment inside the Docker container, okay, you can just use the database. Okay, so I can start the DB service. Okay, here you on the up command, you can specify the service that you want to start. Okay, so I'm going to start just the DB service. Okay, so if I Docker compose PS, I will see that the DB container is running and the Django container is not running. Okay, and I can get onto my Pypenv shell and run a Python manage run server, for instance. Okay, I use run server plus that gives you some tools that are useful for debugging. So here I get a message, okay, saying that I didn't run my migrations, okay, and of course this will fail again. But I wanted to show is that you can run your application using the run server without Docker. Still use Docker Compose to manage your dependencies. Okay. Again, if you're using a project with database and server, I don't know, Elasticsearch, whatever you need, you can create a Docker Compose file to manage to start those services, and you can develop Django as usual. Okay. Okay, so let's now again initialize our database. Okay, so I can do it from here instead of doing it inside the container. I can migrate my application. Okay. Then if I run, I will not get the missing migrations anymore, and this will of course run. And now I can also create my super user. Okay. So I can run manage create super user. Okay, let's call it admin at admin.com, and let's put a password. Okay, so I have my super user created. Okay, so I can log in. Okay, and I have. Now we are developing using the run server plus run server command, and using the database that was initialized using Docker Compose. Okay, so let's move on. Okay, again, I mean, you can do all this also with Docker. Okay, as the database, I mean, is configured to persist the container contents. So I can tell Docker compose to stop the database engine. Okay. And I can then start the database and the Django container. Okay. Okay. Well, what's wrong here? Oh, I need to run the migrations. Yeah. I'm to compose run Django Python run Python manage py like. So when I stop my container, I mean, I said that it was configured to persist the database files, but it does not seem to. Okay, so I'm not sure what's going on here. Let me see. So migrate. Okay, migration seems to be. Oh, sorry. Yeah, the migrations are running. Are in place. I think that this is what's wrong. Yeah, here it is. I'm sorry. For instance, for a moment, I thought that the database was lost when I stopped the container, but not. I mean, I was just looking at a wrong log file. So I saw this message, but it was a good message. Okay, then the application was started correctly. Okay, so now we have again our development environment running with Docker. Okay, so basically what I want to show here is that you can do what suits you better. I mean, if you want to run all the environment from Docker, you can do it. Now, if you want to run just a database and run your Python application, Django application from your shell, you can do it also. Okay. And of course, I mean, if suppose that we are running right now, you're running our application from Docker, right? Yeah. So when I browse, you will see entries here on the log. Okay. If I then change, let's change a view to let's change this to home2 is going to raise an error. Okay. But you will see here that that the application was restarted. Okay. I'm not sure about this error, but I think we can ignore it. But what I mean is that when you make modifications to your local environment, the Docker container will restart. Okay. And of course, this is going to raise an error because the template home2 is surface. Okay. So I can get back this to home. The application will reload again, and this will be fixed again. Okay. So enough with Docker. So let's talk a little bit about Git hooks. So Git hooks are a way to make sure that the developers in your team run a certain tests, okay, a certain number of tests on their own environment before pushing code, okay? So these are a set of different tools that we use at Vartis to run against Python projects. As I showed, all these scripts are configured in the scripts directory. They have their own configuration. This is just a suggestion of configuration. You can then configure the way you want. So to configure these hooks, it's just as simple as copying the scripts into the Git hooks directory. Okay, so inside the hooks directory of the Git folder, there are some templates. Okay, so you can see all the things that you can hook on. Okay, when Git is doing something. So we're gonna use the pre-push script. We're gonna override the pre-push script, and also we're going to override the commit message. Okay. What the commit message does is what we do here is if the branch we are standing on starts with the number and a hyphen, we get that number, and then we add on the commit message a refs column and the number of the issue, just to make sure that we reference the issue on every comment. And we do that, I mean, this works because we use the standard of starting a branch number, about the branch name with the number of the issue. And that is something that, for instance, GitLab does automatically. But if you do that, every commit message will have that. And on the pre-push, we run all these tests. Okay, we start by verifying that there are no uncommitted changes. It runs Flix8, Pilot, PyTest, ESLint, and yes, CPD. By doing this, we make sure that the builds of the continuous integration environment usually don't fail. Okay. Okay, so I installed my hooks. So for instance, I can let's do this. Let's pass some variables that are not being used here, and this may trigger a local build failure. Okay, so I can git add the views, git commit -n, adding some unused variables and used variables. Oh, I'm sorry, I forgot to change the hooks to be executable. Pre-push and commit message. Okay. So now if I want to push this to my remote, the pre-push should be run. Now it's running Flix8, and I get okay, so I'm getting some unwanted messages here. So this is running the Flix8 on my settings file, and I think this should be ignored. Let me check that. Replicate. Yeah, it's ignoring settings. It's on the exclude list. Let me check one thing. Well, I'm not sure why this is not. Let me check one thing. Okay, it should be taking the configuration. Let's see. If I run this manually. I don't know why this is not working. Let me check one thing. Okay, seems to be an issue with the Flake8 configuration file. I will disable, I'm sorry, I will disable the pre-push hook because I don't want to spend time tinkering with it. But, and I'm gonna review this configuration, but this should make sure that all these checks are run on your development environment, okay? So let's continue. An intro on pipelines, okay? There are different project management tools, such as Bitbucket, which is the one we're using now, GitLab, GitHub, of course. All of those have some kind of implementation of pipelines, and lets you run different operations on your whenever the developer contributes code to your project. Okay, so we decided to use Bitbucket for this tutorial because Bitbucket has a free plan with 15 minutes of running of runners per month. This can, of course, be done on Travis, for instance, with GitHub. It doesn't have these limitations, but when Bitbucket released this feature last year, we wanted to experiment with it and set this up. If you go on your project to the pipelines section, you can enable the pipelines. These are disabled by default. Okay. Yeah, this detects the pipelines file that's on the repository. Okay. We will take a look at it in a minute, but I'm going to enable the pipelines. Okay. So now I have pipelines enabled, and this is running the pipeline for the first time. Okay. Okay, so let's see what is the pipeline do. The way the pipeline is defined on this project, okay, it has two initial build phases. Okay. And let's take a look at the Bitbucket pipeline file. So here you have this parallel element. You run steps in parallel, okay? And the first two are the build and the build.js that we saw were running. The build, what does is uses pip to install Pypenv. And then install dev dependencies, okay? it installs dev dependencies because we want to run then flake8, Pipenv, and other tasks. And as this step generates an artifact with all your dependencies, we want to cache this, okay? So then we can reuse it on the other steps, okay? So this sometimes it's tricky because sometimes if you modify your dependencies, the build pipeline will use the same the cached artifacts, okay? And you can go here and, for instance, delete these artifacts, and they will be generated again on the next build, okay? So I'm not surprised the flake8 build failed. I'm not sure why. Let's see if I can troubleshoot this. Comp settings. I mean, well, I really don't know why it's getting the conf directory here. So I'm going to do something. I'm going to disable this pipeline step. I'm sorry. But it should not be checking the comps settings step here. Okay, so altering your pipeline is easy. I mean, I can just delete this step and it's gone. So now I can, okay, let's see if I is correct. Yes, add debug pipelines, git commit, sum, remove flake8 step, git oh, okay, git push, okay. I'm a bit embarrassed because of this, but oh yeah. I'm gonna rebase. When I enabled the build, Bitbucket generated a commit that is not on my local branch, so I just rebased it to get it, and then applied my commit, the last commit on top of it. So now I can push, and this will trigger again the pipeline, the build. So we have a second build. And we can see that the flake8 step is not here. This build environment step is also generating the Pipenv artifact so that these steps can use it again. Let's wait until it finishes. Oh, but I failed too. Oh yeah, well, here it is. I have my my foo and bar variables that I set marked as failing. Okay. Now I know why PyTest failed too. Let's see, PyTest. I'm not sure about this. Okay, let's fix first the pilot and see then the bytest issue. So to fix the pilot error, I just need to remove these two variables that are unused. Okay, and then I can with status with add project use with commit -m fix pilot error and then git push. Okay, this will of course fail because the pytest step will also fail. So let's try to see what's wrong there. Okay, so there's one thing that we can use here. Okay, so to understand what is going on with this failed pipeline step. Okay, so the way we can do that is trying to run locally this same step on our local environment. Okay, so to do that, we can do this. Okay, so there's a section on how to debug a pipeline. So what we can do is we can start a Docker container with the same version of the Python environment where this where this fail step is running. So I can, well, now it's it didn't fail, but supposing that that it failed, I can do this. I can start over a new Docker container. Okay, with this specific version because it's the one that is being run on Bitbucket. Okay, now I try the container, and now I can initialize. I mean, this is the initialization that the Docker that the pipeline step is doing. Okay, let's do this. So what I'm trying to do here is I'm trying to run a command the same way the Bitbucket step would do it. Okay. What's no problem here? Okay. So pipem install that. Oh, where am I? Okay, let's start over. I'm gonna install pipem here. Okay. Okay. Yeah, these two steps are inverted. I mean, you should first modify your path before being able to run pipem. Okay, so now I created my environment, and then now I can rerun the step, which is not pilot. It was the tests back on that pipeline. Let's see what happened. I can run this same command. I'm gonna copy it from the pipeline here. PyTest, here it is. Okay, once this completes, I know it's a bit tedious, but sometimes it's useful to try to isolate the problem that you're having with your pipeline and run it on an isolated environment. Yeah, so that is what we are trying to do here. Remember when I mentioned that Pipenv was slow, a bit slow? Well, it is. And also my connection may not be helping too much. Okay, so now I can run PyTest inside the Pipenv, okay, with my settings and see if something fails, as in that pipeline that failed. This is running the tests. By the way, we are on this project, we're using PyTest to run the tests. One good thing about PyTest, okay, just a warning, I'm not sure what this is about, but oh yeah, I'm missing a directory here, but it's just a warning. I was thinking that one good thing about PyTest, let me see where okay, is that lets you define these fixtures, okay, which are functions. Yeah, inside these functions, you can generate like initialization data for your tests, such as fixtures, okay? And then you can, when you run your tests, you can inject those fixtures to your function, to your test functions, okay? So this test is getting a random string fixture, okay? But not the function, not the function, but the execution of that function, okay? So in this case, you can make sure that that this random string generator will be run and will be passed to this function. And you can use Faker to generate fake data for your test and fake models for your Django tests. It's really nice. Okay, so back to our pipeline. By doing this, what I did was to run the tests step on an environment similar to the Bitbucket pipeline, and it passed. I really don't know why this failed here. Maybe if I rerun this, we'll go through. But in any case, we have a third. The final pipeline was successful after I removed, of course, vacate. Okay, and then we have this deploy step. Okay, that we have set it to manual, but it can be run automatically, of course. And the idea of this deploy is to deploy your application onto Heroku. Okay, if I click run now here, this will fail because I have not set up the Heroku credentials, and I have not even created the Heroku application yet. I want you to see this. I mean, we're using this deploy script that requires two things. It requires the Heroku app ID or app name and an API key. Okay, so I'm going to show you now how to create these settings, how to create this application, and how to configure so that you can deploy on Heroku from your pipeline. Okay. let's go back to the README. Hooks, pipelines. Okay, Heroku. So let's go to Heroku. Let's create a new app. We have a new app. Let's name the app Django Bootstrap PWC 2020. Okay, and let's create it. So I have my app. Okay, I can browse to it. Of course, it's not initialized. Okay, but the URL of the app is the ID that you've set, .herokuapp.com. Okay, and let's see how we can deploy our application onto this environment. Go to our README. Okay, the way it works is, or the way you can deploy a Heroku application to is by using Git. Okay, when you initialize your Heroku environment and your application, you need to log in onto Heroku using the Heroku client. Okay, this will open a browser session. When, if you have not logged in, as I am, you will be prompted for your credentials, and then the application gets authorized. Okay, so now I'm logged in on my console to my Heroku application. Okay, so what can I do here? So first, you need to set up your Git remote. Okay, and you do it by doing this Heroku Git remote, and you want to add Django Bootstrap PWC 2020. Okay, and these setups on my local environment, my development environment, and new remote. Okay, so if I do Git remote, I have two remotes, Heroku and my origin. Okay, my origin is pointing to Bitbucket, and Heroku is pointing to the Git repository that Heroku gives you. So I can now, if I want, I can push my master branch or my development branch. I mean, you can push it to the Git repository, to the Heroku repository, and the deployment will start. Okay, so I can do this. So before doing that, let's take a look at one file that Heroku needs you to set, so you can tell Heroku how to run your application. Okay, so we have this proc file. Okay, so we're telling here that we have a web process. Okay, our application, and then we want to run it with gunicorn. And this command line. Okay, we're basically running this WSG application with gunicorn. Okay, and this log file setting lets Heroku grab the WSG application output so you can see it in your log. Okay, and this release phase is a special element that lets you run some operations after the web has been built. Okay, so on the Heroku like build process, build step that Heroku will identify that this is a Python application, and that actually that is a Python application, and that is application that uses Pipenv because it will detect the pip file and the pip file log. It will install the dependencies, and then it will run the Python application using this. And after the build has been successfully submitted, it will be released after this command is successful. Okay. So this lets us make sure that whenever we release a new Python application, we run the migrations on the Heroku environment. Okay, so let's try that then. If I do a git push Heroku master, I'm going to trigger the Heroku development process. Okay, so let's go through what is going on here. Okay, so here, so here, Heroku is trying to detect what my application is about. So it detects that it's a Python application. Okay, it looks for a requirements txt file. As there is none, it grabs the Pipenv file and the pip file log. And on the Pipenv, remember that I have set that on the pip file, remember that I say that I want to run Python 36. That is why I'm getting installed Python 36. And it is funny because it's using Pipenv from 2018. It's not using the most recent Pipenv file. Okay, something wrong happened. Okay, what's wrong here? We didn't like something. Oh, okay, I see. So I pushed when I pushed my master to the remote repository. Heroku is I mean, I have not set which is my settings module. Okay. So it is grabbing the settings module from the manage file, okay, which I have here set a default. I think that the Django settings module is conf settings local. So what I need to do is I need to configure Heroku first, okay. Okay, it says you will fail because you have not installed the requirement environment, the requirements. So we're using the production settings file, and why is this? I mean, we're using the production settings because we have everything prepared here on the production settings file to use environment variables. Okay. So all these are taken from environment variables that we are going to set on Heroku. Okay. So first, let's tell Heroku that we want to use the production environment instead of the production settings instead of the local. Okay, so I issued a Heroku config set command, and then you say what's your setting name and what's the value. Okay, and this sets the environment variable on Heroku. You can do this also on the Heroku interface. Okay, on settings on the Heroku environment, you have these config bars. You can see that I have already this set. Okay, but I'm gonna set them on my terminal. So here you can set the Django secret key. Don't do this. I mean, you say generated. There are tools that let you generate the Django secret key. Then let's set the allowed host, okay? The allowed host, so Django has a feature that lets you control which hosts will the application respond to. This is a security feature, okay? So by doing this, we are only allowing the Django application to respond to a specific domain name. Okay, and the domain name we want to use is the domain name of the application, okay, which is Django Bootstrap PWC 2020 herokuapp.com. So setting these two here, and the database URL. Okay, so database. By using Heroku, we can use these add-ons. Okay, so we can tell Heroku I want to use Postgres database provided by Heroku. Okay, there's a free tier that we can use. You can provision this. Okay, so now my Heroku application has a database attached to it. Okay, so if you click manage here, or if you click here on the link, you will go to a configuration screen of the database. Okay, there are some limitations. I mean, you can have only 10,000 rows. I mean, it's good for development purposes or for quick, yeah, for very small applications. And here on the settings, you can see the credentials. Okay, so what we want to do is we want to copy this URI that has all the settings here. The username. So this is the username, the generated username and password, the Amazon instance, and the generated database name. Okay. So then we go back onto here to the console. We paste the database URL. And now we should have our application configured appropriately. Okay. Let's go back to the settings just to check that. I have here all these settings. This database is going to be deleted, by the way, after this call, so after the session. So I'm not worried about showing these credentials. Okay, so we want to rerun the deploy. But what happened if I push to Heroku again, the Git repository, will again detect the change and will start over. I thought it would not. I thought it would not grab the change because I have already pushed, but it did. Okay, so now it is again installing Python, pip, dependencies. There may be some cached items here by Heroku runtime. So this may be a little faster. Okay, so now the collect static was successful. Okay. And now the release command is going to be run, and the release command is the migration. Okay, so all the migrations were run, and now we should be able to browse the application here. Okay, success. We have our application here. Okay, so we have a problem here because we don't have a user on this environment. Okay. So in order to solve that, Heroku has a shell command. A Heroku run command. Okay. So I can do a Heroku run. And remember to use Pipenv because this is running on over Pipenv. Pipenv. I mean, you can do it the way you want, but you can do this Pipenv run Python manage py create super user. Okay. Okay. No. Okay. Pipenv here is necessary. Okay. I can run up Python directly. Okay. So here I'm prompted for a username. I'm going to be named admin at admin.com. And I can use a this password again. So I can run these commands to initialize the Django super user. So I can log in here. All right. Okay. So now we have our Heroku environment running, and we can trigger, of course, our deploys from here, from the pipelines. So let's see that. So before doing that, let's do it. So let's do a small and quick change. So let's add another a URL, another view to our app. Okay, let's call it home again. Okay, we will also render the home template. Okay, let's then update our URLs. And let's call this home and views.home again. Okay, let's name it home again. Okay, so I set up a new view that renders the same template as the home page. I've added a new URL that responds to that view. And so let's on our template add a link to that. Okay, so let's modify our template. So that generates a URL home again. Okay. So let's do some steps back. Let's start our Docker containers. Okay, so these are running. This should have gotten the change. Okay, I'm just trying to see locally if this change was successful. Okay, I have my home again. Remember, this is my local environment again. Okay, this home again is just browsing to /home again and rendering the same template. Okay, so it seems to be good. So I'm going to commit this. Let's review this one more time. Okay, looks good. Adding a new a new view. Okay, so I'm gonna push to Bitbucket. Okay, I'm gonna push it to the repository because I want all the pipeline to run, and then I want to manually trigger the deploy to Heroku. By the way, this trigger is set to manual. That is why you get a button. But you can set different criteria to specify when you want this to happen. I mean, you can run this when commit is done on a particular branch. Suppose that you want to deploy when a change is done on the master branch or on the dev branch, or when somebody creates a tag on the Git repository, you can do that too. Okay. So the pipeline is running. PyTest pilot. Oh, I may get a copy paste editor error here. Let's see. No, that's not enough duplicate lines. Let's wait for pilot. Okay, so now I am entitled to run this. Okay, so when I try to run this, don't be surprised, this will fail because I have not set these variables, the Heroku app ID and the Heroku API key. Okay, so let's set those. Okay, so I need to set those two variables. Okay, Heroku app ID on the Bitbucket repository. Okay, so the Bitbucket settings has a pipelines section with repository variables here. So I can set, okay, yeah, I can set my Heroku app ID to this string. This is the ID of your app. Okay, this is not some secret. And then you need to generate and set token. Okay. So to generate the token, you do it by this, by calling Heroku authorizations create. And the token is this string. Okay. This is a secret string. Okay. That I'm going to secure. Okay. And of course, afterwards, I'm going to delete this application, so you won't be able to see or to do anything with it. And this is the Heroku API key. Okay, so I'm setting this. Okay, so now I can rerun the deployment step, and with the variables, we should see that on the Heroku application, we have the other item there on the template. Okay, but let's wait until the deployment finishes. Okay, so the deployment finished. This screen I commit, but the way this pipeline is configured. So I mean, this screen means that the deployment was submitted to Heroku, but not necessarily that that was successful. So let's refresh here. Okay, it was successful because we found that we have the second link here. But if you go to, I mean, I'm going to show you what is happening under the hood on Heroku. You have this activity tab here in your app. And you can see here the two steps, okay? The build step, and the build was successful. And then the release of the app, okay? And sometimes if something fails with your migrations, this will fail. But the Bitbucket deploy step will be green. I mean, you can use Heroku's API to query whether this step was successful or not, and mark the step as failed. But we have not done that for this tutorial. So good, we have this running. So the last thing I wanted to show you is how you troubleshoot errors in a remote environment. I don't want to use the name, the word production, because it's not a recommended production environment. But what happens when you have errors in your app and you want to know what is going on? So Heroku has a logs command. Okay, you can see logs of what is going on within your application. I can do -f to follow. No. See, logs tail -t. Okay. So if I get, let's do this. Let's change our view, our home again view, raise an error. Okay. So I can do raise exception. Oh no, this is an unexpected error. So let's see what happens in the Heroku logs, and let's see then how we can improve this. So git add views, git commit -m, adding error view, git push. Again, if we go through the pipe, okay, we have 5 to go. So obviously, when this finishes and we deploy the app, what I'm going to expect is to have an error when I click here on this link, and see how we can get more information about that specific error. Okay, 2 to go. Okay. So let's run the deployment command. I mean, again, this can be automated. When the pipeline is green, it can be run automatically. We're deploying this onto our Heroku environment. If you go now, when this is running to the activity tab, you will see that Heroku detects, or it is running, right? So this finished, and we should have the release stage running. Okay, it finished and seems to be successful. This is loading. The app has been restarted. So error. Okay, yeah, because I was in the home again already. Okay. So if I browse to home again, I will get this error. Okay. So they said we have these logs from the app. Okay. From Heroku. But depending on how you have configured logging in your app, you may not get enough information. So one thing that we find very useful too is using Sentry. Okay, Sentry is a platform that it is built using Django that lets you. It's like a hub where you can send all the errors from your application from different environments, even, and then it lets you filter them and analyze what's going on. So let's create a Sentry project. So I am already logged in here, so that's why I'm prompt to create a new organization. So after you create the organization, you are prompted to create a new project. Okay, and you can throw in here projects of any technology. Okay, there are drivers for Sentry for all these technologies. I'm going to select Django. Okay, and I'm going to name this Django Bootstrapping, Django Bootstrap, PWC, Django Bootstrap, just that. And I'm going to create a project. Okay, so when you create a project, Sentry suggests you how to configure your Django application with the SDK. This template that we are using uses Raven, okay, which is a different implementation, but it's pretty similar. But the important part here is this DSM, this URL, okay. We want to copy this URL because we want to configure our app to use it, okay. The application, the production settings already have this configuration in place, okay. If we open the production py, you will see these two things. We will see the Raven config setting, which is something that the Raven plugin requires. I mean, you have to set this variable, and you can set other things such as how do you want. I mean, you can even let Sentry report to you which commit is your application standing on. So you can see that your application failed on commit, I don't know, 1, 2, 3. And then you have to enable, you have to add to your installed apps this Raven compact Django app, okay? So all this is already in place. I just need to tell Heroku to use this configuration. Okay, so I can use config set raven tsn and paste the complete URL. Okay. Okay, so the application gets configured and restarted. Let's go back to the app. I'm gonna go to the home page. Okay, so when I'm gonna click here, we're gonna get the error, okay? And this should have reported the error to Sentry. Let's go to the projects. Let's see if maybe there is something missing here. Let me check. Here's in the production. Using Raven DSN, is this correct? Using the production setting, using the DSN. Yeah, this is right. Yeah, seems to be right. Let's see. Okay, let's see what happened here. I'm trying to think which could have gone wrong. With our application. Let's see. Let's give it a new try here. It should start getting the errors here triggered, which is not happening, obviously. Maybe I should restart the app. Let's say, let's do this. Okay, I'm gonna force a commit. If I can push to the Heroku master, I don't think so. So I'm triggering a deploy to get the application restarted. Maybe when I set the credentials, the environment variables, the Heroku application did not get restarted. So I'm doing this just to force that the application gets restarted. Maybe I should have used the Heroku client to do that. Okay, seems to have been released, this application. Okay, yeah, P12 released. Let's trigger the error again. We'll keep our fingers crossed to get some activity here on Sentry. Let me check the DSN again, but Seems to be right. Let's give it one final shot. Maybe this. No, this is correct. Okay, I'm gonna surrender now. I don't know why this is not showing up. I mean, the arrow should have appeared here. But okay, I mean, I'm gonna see if I can figure this out later and let you know. But we are done with the tutorial. I don't know if you have any questions, any suggestions, something to discuss. I cannot hear you, Calvin. I'm sorry. Okay.
Actually, I was going to make a comment here that to not be bashful, but we've been using Sentry with the Loudsform site that everyone's using to watch the conference, and it's awesome.
Yeah, it is. It is really useful. We have we use we don't use Sentry.io. We use our own instance of Sentry for our projects. But I don't know what's going on here. I mean, it seems to be configured appropriately. I'm gonna play around with it later to see if I can get this. I can get this working.
But it is a fabulous tool. We have tracked down ridiculous performance problems instantaneously.
Yeah, it is. It is. I really recommend it to for any project of any technologies. I mean, not only Python. We even use it on React Native applications to track what happens on the user devices. But yeah, it's really cool. I'm a bit frustrated this week. I could not show this, but maybe next time. Okay, so I don't know if there are any questions, but this is pretty much the tutorial.
Yeah, please take advantage. We've got another half an hour still left before the cocktail hour, and you've got Paulie here to answer any kind of questions.
I had at least one, maybe two. So, do you still recommend using Python version management if you're running your actual app inside a Docker container to handle the Python version instead? Are you still going to use Pipenv in that case? That's the first question.
Yeah. So it depends. I mean, whether you want it or not. I mean, so it depends on how you define your dependencies. If you are using a Pipenv log file, because you want to be sure that your environments will be able to be replicated with the same dependencies. You would of course want to use Pipenv under the hood will use virtualenv, so you will get a virtual environment. But I mean, you can use just a plain requirements file and just pip install the dependencies. Yeah,
but
it is not needed.
I have opinions here, if you don't mind me butting in.
Sure.
I started out the same way. I thought if I'm in a Docker container and it's already its own like sandbox, why would I need the VM? Until I realized with multi-stage builds in Docker, it's a lot easier to make a build container, build everything I want, all the dependencies that are needed, put it into a VM in that container, and then just copy that VM into my like deploy container afterward, so that I get the advantage of a nice small size. unwinding all the bits from like where the user local share Python 2.7, Python or Python 3.7 packages stuff may be into your build or your deploy container is tricky. Well, it could be difficult, where if you just make a VM, like I just make a VM at /app, and so it'll be like /app bin, /app share, /app lib, and then I just copy /app into the new deploy container. It makes for a really clean process. And so I got that idea, that's not original for me, obviously. The warehouse project, which is PyPy, the Python package index project, they do this, and I kind of wondered why, and I started off not doing it, and then when I got into like real world deployment, it made a lot of sense.
Thanks.
Yeah, I don't want to monopolize all the question time, but do you have any familiarity with like integration with, say, Django and like the Elk stack or anything like that for this metric logging, or is Raven your main experience? Well,
with Django and what? Sorry, I didn't get.
Like more infrastructure management, like the Elk stack, like just Elasticsearch, Kibana. I don't know what the last letter of the Elk stack is, but
Logstash.
Logstash, thank you.
Logstash, yeah. Yeah, I mean, so those, your environment can have any kind of dependencies. I mean, what I would recommend is creating a Docker Compose file with all your dependencies and how you want them configured, so that your development environments are repeatable, and everyone on your team can easily set up all the tools and dependencies that they need to work on the idea of using Docker for starting your development dependencies is to allow developers to focus on your app and not on how they need to configure the dependencies they need.
Good, thanks.
Hi.
Hi.
Muchas gracias por la charla. Thank you for the talk. I would like to know if you use also Docker for deploying this kind of projects in production.
Yeah. So I mean, I'm not using Docker for Python applications, but at Devartis we are deploying Rails applications using Docker containers on AWS using Beanstalk. Also on Azure has also some good and some nice integrations with Docker containers for production.
Thanks.
Yeah, we're using Docker containers to deploy LoudSwarm. So all the stuff you're using to view the conference is coming off of AWS Fargate containers. Actually, all the things you talked about in this talk, I think 99% are almost exactly what we're doing to deploy this application.
Nice.
Excuse me?
Yeah, go. Please ask more questions.
What is the difference between Kubernetes and Docker? Like the difference. Kubernetes, Q-U-B-E-R-N-E-T. What's the difference?
So, Talon, do you want to answer this? I mean, I have not worked with Kubernetes.
Okay.
Professionally,
I can take that. So, Kubernetes is an orchestration platform that uses Docker containers to deploy your application. So it adds in an extra layer of automation into the management of the deployment. So for example, if you deploy a Django application into a pod in Kubernetes, it can then scale automatically or ensure there's always so many instances of your Django application running, where Docker is just the foundational packaging technology of how you can deploy your application into Kubernetes, Fargate, ECS, Docker Swarm, Docker Compose. it's used across all kinds of different technologies, where Kubernetes is one specific one for the orchestration. Does that answer your question? Chris Williams is here. I could have had him answer that question. Oh, I can't hear you, Chris. You got something muted someplace.
I was listening to the question. I had you guys up, but I wasn't in the Zoom session, and that question was asked. I was literally on a talk with Cormac Hogan of VMware yesterday, going through all of the ins and outs of orchestration layers, Kubernetes, container utilization in the new Tanzu, the Tanzu grid for VMware. So I was about to jump on, but then I realized there's a time delay from the web conference in Loudswarm versus the actual Zoom. So when I logged in, you had already finished.
Yeah, there's like a 1 minute delay from the live stream inside the Zoom channel. Tomorrow it won't matter because no one's going to be in the same like Zoom with the presenters. The galleries will all be people watching the same stream as everybody else.
Oh, gotcha.
Yeah.
So I guess I have another question while we have some experts in containerization here. Yeah. So when I'm building an application that might have a shared like instance, how do you scale like database connections and things like that? Like, are you building like all your services to be stateless and then sharing like a single instance, or like, or do you have to have some sort of like intermediary to deal with like location of like on which database store, like, or I guess I'm so naive. I don't even know how you would manage that. So like if you have two users and two instances of the data, then do you have to have some intermediary say, oh, well, this person is on this resource and this person's on this resource? Or
so Cal, you want to take it, or you want me to take it?
Well, there's a couple. I mean, there's probably different angles to this.
Yeah.
And the thing you're talking about is probably really sharding. And you really only need to worry about that when you get to like a very, very large application. And you shouldn't worry about that until you get to a very large application.
Right,
because it adds in a lot of overhead and complexity to your application itself, which you don't want to deal with.
Right. Yeah, no, I was just watching an instance, and you're right, it was at high volume. It was where I'm sure you know who George Hotz is, or maybe you've heard of him, but he was building a storage for his, and he used sharding, and so he used like I didn't look into it. He built it in Go, but basically the idea was that he needed to have kind of like a Nginx style caching of video footage for his Python machine learning application. So he was working on self-driving cars, and basically there were tons and tons of video recordings that were compressed and stored. And this was one of those instances where these training things were happening, and he had to access them, and the instances of where that was stored wasn't a single instance. And so like I was wondering, like, I mean, you know, I naively will mount just like a file system or like an S3 bucket or something and just use it in my application. But then, like, you know, you hear about these guys that are doing like microservices, and they're like, oh, that's an anti-pattern. You shouldn't mount it. You'll end up with like thrashing and locks and all this crap that I don't know enough about to have an opinion on. But
are you familiar with the concepts of persistent volume mounts and persistent volume claims and storage classes in Kubernetes?
Nope.
Okay,
so it's about my pay grade.
So in Kubernetes, there's the concept of a persistent volume, and a persistent volume lives outside of the namespace, and it is a disk. And so Kubernetes so you've got your disk, your actual disks, and then you've got your persistent volume, which is a logical abstraction of your disks, and that's outside of the namespace. And then you have within the namespace, you have your persistent volume claim, which is the third tertiary abstraction of the persistent volume. So the persistent volume claims the persistent volume. So you've got like two namespaces, and then you've got a whole bunch of persistent volumes, and then each container in your namespace has a persistent volume claim for stateful data that it needs to store. The claim tags a persistent volume that matches the needs for it. So like if it's a read write, then it'll look for a read write persistent volume. If it's a read only, it'll look for a read only persistent volume. If it's got a certain speed, it'll look for that. And there's different profiles and patterns that you can use for that. Then on top of all of that, there is the storage class itself, and the storage class auto satisfies persistent volume claims. So you can manually create, an admin can manually create persistent volumes, or you can create a storage class layer, which when a container makes a persistent volume claim request, the storage class goes, aha, you need 10 gigs of blank at this speed, and read write or read many or read once or whatever. And the guy that you were talking, I'm sorry?
And this is all very complicated and fraught with places for it to go wrong.
Yeah. So all of that is how stateful data is satisfied within an orchestration layer like Kubernetes.
Yeah. So for example, for our application for LoudSwarm, it's running on Docker containers inside of Fargate. If the CPU usage gets to X amount for so long, Fargate automatically will scale out to another CPU, another instance of the application for us. We just put that into Terraform, say go. If this all happens, then do those things. For persistent data, we're strictly using RDS for our database right now. And so Amazon's managing the...
Yeah, I'm a lot more familiar with RDS.
That
That's
yeah,
mainly, that's the only thing I really have exposure to.
Right, and the Heroku application that Polly showed, that's just an RDS. You've got a slice of an existing RDS application in Heroku to do that. And we have in Django, using Django storages, any media data, like if you upload a file through a file field inside of Django, that just gets put on an S3 bucket, like automatically.
Yep.
So our persistent storage is just S3, and then we rewrite links from CloudFront or through the application to just pull the data right off of S3.
Okay, yeah, that's kind of what we have going for the one internal app that we just recently built. Is we used S3 for image storage and things, and then we did RDS for all the data, and it's super easy just to snapshot that.
It's nice and simple. For example, we have Sandbox in a production instance, and if I want to put the data from production back on Sandbox for testing, like you can literally go into the S3 console and click a button to like replicate this key, this bucket.
Yeah, and just take the database URI and then plug it in for the credentials. Yeah.
Yeah, done.
Okay.
Yeah, I guess I should have stated that the design that I was defining was how Google does it.
Yeah, No. I really like the explanation because it helps me understand it. Honestly, I haven't had a real use for microservice architecture, but Docker is very interesting, and I understand scaling in front of Docker and load balancers from a networking perspective. And that was always one thing that befuddled me is like, so like, all right, you have all these microservices and they're trying to orchestrate, talking to, because like I'm familiar with like mounting data onto, a Docker image, right? Like mounting a file system or whatever, but I just didn't understand that at scale.
Yeah, so we try to avoid mounting any file systems into a Docker container at all, period.
Right.
Those containers for us are considered immutable. Like
Right.
once it's been burned, and put into the registry, we use it as is, which is nice. So if you are interested in this stuff, is it tomorrow or Friday that is Carl Meyer's fireside chat? I don't remember on the schedule.
That's tomorrow.
So tomorrow lunch, do not miss the fireside chat, and put any of these kind of questions you have like this into the, where are we gathering those? I think hallway track, you can throw some questions in there, or in the keynote while we're having it.
Are you talking about track 3? You want Kubernetes, you must know Docker?
No. This is the fireside chat with Carl Meyer. It's a lunchtime.
Oh, okay.
It's over lunch.
That's tomorrow, yeah.
Yeah, so tomorrow lunch, noon Eastern. Don't miss that because, so he works for Instagram as one of their main like site reliability engineers.
Wow.
And they don't have a traditional, well, I should say, I'm almost like reversing my words here. They have a monolith. They have a Django monolith server that still powers Instagram on the backside. And I got a chance to grill him on questions a couple months ago, which spawned the idea to do this fireside chat, as he's very transparent about how they do it. You want to know any secret sauce? There isn't any secret sauce. He's going to tell you like what they do, how it works.
Yeah,
And
that's
that's
Django's really big claim to fame. Like, we support Instagram, so we are you. Like, literally, it was on their homepage forever. I haven't checked since Django 3 release, but yeah, Django's just like, you think you know, our patterns are obsolete? Think again.
Yeah, that's really good. It's really good. He's a great speaker. He's super easygoing. He's a really good conversationalist. It'll be a fun session.
Right. Yeah, I have a meeting I got to get to, guys. But thanks again for the talk. Honestly, that was a very ambitious track. I was super excited to see it, and thanks for showing off everything from Docker to logging to, you know, virtual environment management and configuration and everything.
No problem.
Yeah,
you enjoyed it.
We really appreciate our speakers, and I know you put a lot of time and effort into this. Even if it was something you've done at DjangoCon before, it's no small effort to try and do a tutorial, especially when it's virtual like this.
Yeah. Okay. Thank you, guys.
So we'll just go ahead and wrap this up. We've got, so if you come back tomorrow and Friday, we'll have 2 full days of regular sessions. So get your schedule prepped by looking at the pythonwebconf.com. Check all the talks. I want to thank our sponsors, 6 Feet Up and JetBrains, and then all of the media sponsors and silver sponsors and community sponsors that are listed on the website. I won't spend too much time there. The most important part about tonight is the social, of course. We will have, starting in about half an hour, a very impromptu, casual cocktail hour. If we get a lot of folks in the room, what I will do is I'm probably going to use the breakout rooms feature in Zoom, and I will just auto split people up, give you guys a couple of questions to kind of go around the room and answer, so you can get to know some of the other attendees, so that there's actually an opportunity for more than one person at a time to just talk inside the Zoom room. So again, Polly, thank you so much for being a speaker here at the Python Web Conference. We couldn't do this without folks like you stepping up and joining my crazy adventure. I want to thank all the attendees for showing up and supporting our awesome speakers. We will definitely see you tomorrow. If we don't see you before at the cocktail hour, we will see you all soon. Thanks again. And if there's any more questions, don't hesitate to put them in track 1 in the Slack channel. That'll be available. This recording will probably be up and online in about 20 to 30 minutes. So if you actually missed something and wanted to go back and see it, you can do that right away.
Oh, that's fast.
Yeah, please, if you have any questions regarding the tutorial, or if you got stuck with anything, I will gladly help you.
And so you'll be around the next 2 days in the Slack channels?
Yeah, I will.
Awesome. Yeah, and please, anybody, don't hesitate to do the same, like ask any of our speakers any kind of questions. I've encouraged them all to hang out and be around for us throughout the conference, so they can answer questions and be available.